Okay, fine. Let's get started. So I'll be speaking about how to improve the resiliency of cloud-native applications using OpenTelemetry. And since morning, we have had a lot of insightful discussions around what is observability and what are the different pillars of observability. So I hope that just before lunch, you get some insights about how we can improve the resiliency using OpenTelemetry. My name is Nilesh. And as Janita said, I'm currently working as an enterprise architect for one of the leading banks here in Singapore. I'm also quite active in the community. So if you have part of any of the meetups, you might have seen me talk about Kubernetes in Azure meetup or the Kubernetes K8s meetups as well. And I'm also rewarded with the Microsoft MVP for Azure, and I'm also the first Docker captain in Singapore for my contributions to the community. Now, coming to today's topic, I would like to start with this CNCF Cloud Trail. If you're new to building cloud-native applications, you might have seen this published by CNCF. It's sort of recommended projects which CNCF says if you are starting new cloud-native applications, you can look at these different projects which are part of the CNCF umbrella. And if you want, you can start using some of these projects. This trail is pretty old. I didn't find like 2023 or 2024 version, and some of the projects you see here, they might be a bit old, but still it's a sort of guidance provided by CNCF to say under different areas like containerization, CI/CD, observability, orchestration, what are the different projects that CNCF sees based on the adoption and their maturity, and what you can look at if you are new or if you are interested in some of these projects. If we specifically drill down into the observability landscape, there is also this CNCF.landscape which is provided, and this gives you a drill down of different projects based on their categories. And if we look at observability, again, we see there are a lot of projects by open source project community as well as vendors. And this again is a sort of categorization by CNCF itself under different categories. So I suggest you have a look at these if you want to categorize or if you want to start any of these things. When it comes to observability, we heard about this in the earlier sessions as well. There are three main pillars, the logs, metrics, and traces. And just last month or in December, I was at the Cube Day event and someone asked this question, do you know that now there are 4 pillars when it comes to observability? And I was not aware of it. I think monitoring is being considered as the 4th pillar of observability now. In my opinion, it's good. Technology keeps evolving and we shouldn't be really worried about whether it is 3 or 4. I think over a period of time, we see that different tools, technologies, they keep evolving. If we look at the 12-factor apps, which started as one of the recommendation for building cloud-native applications, now there are 15 factors. If we look at big data, when it started, there were 3 V's of big data. Last time I heard, I think it was 6. If we talk about cloud adoption or cloud as such, there were 5 R's. And maybe some people talk about 6 R's. So again, I think 3, 4 really doesn't matter. What we should focus is what do we need to implement a good observable solution. So for this discussion, we are going to look at these 3, starting with logs, then metrics and traces. Let's see, why do we need these 3? Centralized logging is the first one. And I'll take a couple of examples here. Why do we have to centralize the logs? Now, in my 2 decades of experience, I'm pretty sure the crowd here is quite wide. So some of you might be even more experienced than me. You would have been in situations where the application team doesn't have access to logs and you need to ask the production support team to provide you the logs. Maybe there is an incident and you have to wait for hours just to get access to the logs. I've been in that situation in the past. That's one scenario. So probably that was like 10 years ago. Now, if we look at the current situations, there are other cases why we need to centralize the logs. I've put some examples here. First one is when it is related to application-specific logging. If we look at banking or insurance or any other industries, they might have compliance-related reasons where you have to retain logs for a certain duration of time. It could be 7 years, it could be 10 years. And if you are storing logs, let's say, on your servers and they get rotated, you might lose those logs after a period of time. So that is one reason. The other reason could be when your application restarts. Typically, in case of Kubernetes, for example, if your node gets restarted or your application, you deploy a new version and it gets rescheduled on a completely different node, then your previous logs might be lost if you don't store them centrally. When it comes to the Kubernetes upgrades, many of the cloud providers, they don't do an in-place upgrade. They just replace the node with a new version. So again, in that scenario, you might lose the logs. So these are some of the scenarios where you need to extract those logs away from those resources and store them centrally. Coming to the PaaS services or serverless, again, we don't have exactly the same kind of control that we have in our own data centers. You might be reliant on the cloud provided solution to get access to the logs. So that is another reason why you need the logs to be centralized. Now, I'm using a small demo here, like a banking application, you can say, which has a set of microservices. And in this example, there are 5. We can think of the backend service as like the entry point to this application, and it relies on other services like the account service, authentication, there is Forex transaction service, and all this is deployed to a Kubernetes environment. And then we have Loki, which is one of the solution for log aggregation. I'm using OpenTelemetry here, which is open standard. It doesn't have any vendor-specific implementation. It allows us to integrate different kinds of backend solution, but it centralizes those 3 aspects. So instead of having different SDKs or different solutions integrated in your code, you can externalize that as a configuration using OpenTelemetry, and OpenTelemetry allows us to easily switch the backend. So in this case, I'm using Loki as my log aggregator. But if I wanted some other supported solution, I don't have to make a change to the code. I can just change the configuration here, and OpenTelemetry will take care of sending those logs to a different backend. That is the advantage of using something like OpenTelemetry. So let me switch into the demo mode, and let's see if I can get the screen up here. I have Postman here, and I'm going to run a series of calls here. I think this is going to send 200 requests to the backend service, and some of them will be passing, some of them would be failing. I have the Loki configured to send the data to Grafana. So I'm using Grafana as the way to visualize those logs, and here we can see the source is Loki. So Grafana, if you work with Grafana, you might know that it can visualize data from multiple data sources. In this case, I have Prometheus and Loki configured. So I'm looking at the Loki data source, and I'm looking at the logs. So in this, I can quickly look at the logs, and I can filter based on, let's say, the container that I'm looking is at the backend service. That's my application specific container. And when I refresh the query here or run the query, we will see the output, and it's running right now. It's in real time. So I don't really need to request, like raise a ticket to my application support or production support to have access to the logs. And this is real time, like near real time. So that's the advantage of using these modern day tools to get access to the logs. This also has various other features. So we can do filters, we can define timelines, all those things. And I'm doing raw visualization of the logs here. We can even build dashboards using this data. Now, moving on. The next thing is about the metrics. Metrics are useful when we want to visualize or when we want to look at data over a period of time. Instead of looking at very time-specific data, when we want to look at, let's say, resource usage over a period of time, or if we want to look at any anomalies, those are the kind of scenarios where I would need to have a look at metrics. And in this case, again, the scenarios are related to the container-based workloads as well as the PaaS services. So in this demo, we are going to use, again, OpenTelemetry or the collector. And for collecting the metrics, I'm using Prometheus. Anybody is using Prometheus or has experience with Prometheus here? Yeah, I see some people using Prometheus. It's a quite common solution nowadays to store metrics-related data and to visualize that data here. Good part about Prometheus is you don't really need an agent. It can scrape the metrics without having an agent installed. As long as Prometheus can access your resources, it would be able to scrape. So I'm using this method in this case to scrape the metrics, not just from the application-specific containers, but I'm also scraping metrics from my infrastructure. So in one of the earlier talks, we saw that what are the different things we should be monitoring. It is not just the infrastructure or the application. For an end-to-end observable solution, we need to monitor all. So that is what I'm trying to do here. And for visualization, again, we go back to the Prometheus or Grafana. So let's have a quick look at this. It's not switching the screen. It's not switching the screen. Okay, thanks. Okay, so for the Prometheus metrics, here I'm using a Helm chart which is based on cube state Prometheus. And this gives me a set of default dashboards. So if we look at this particular dashboard, it's giving the compute resources at the cluster level. And based on the data or the metrics that are collected from my infrastructure, I can see which are the different resources under different namespaces and how much usage is being currently utilized, like in terms of the CPU request or CPU limits. What is that my pod or what are the application requesting and what is the actual utilization. So this can be really helpful if you want to resize your pod usage or you want to set the right sizing of your pods for your request and the limits. You can use this kind of dashboard to identify which are the pods which are requesting maybe more resources but they are utilizing less. Same way at the application level, I have another dashboard here which shows application specific metrics, and all this that is shown here can be customized. So I can change the look and feel of this as per my needs. This provides a lot of widgets and different representations of the data. Everything can be visualized the way we like. So that was about the matrix. The last part is about distributed tracing. And why do we need distributed tracing? When I started my career, maybe there were 3 layers in the application, like There was a front end, there was middle tier, and there was a back end. And if there was an issue, we knew exactly where to look at. If your front end is working fine, then you probably go look at your app server. If that is okay, then look at the database. But since the advent of microservices, most of the things have become distributed. And now your application is itself may be distributed across different nodes. So we need something which can give us insights into where are the problems coming from and what is the potential source of error or what is the potential source of the problem. That is where distributed tracing comes into the picture. It gives us insight into the different calls that are happening in the application and which is the possible source of the error. So for this demo, I'm using again the OpenTelemetry collector, and it's sending the distributed traces to Jaeger. And to visualize those traces, we can again go back into the Jaeger UI. And find the traces here. So you can see at the top some bubbles which will show different sizes, and we will also see the time that is taken for each of the calls or each of the service invocation. We can find out if there is any problem as well. So let me go back and trigger some of the invocations again. So you can see there are some red bubbles here, which means there are errors in the service, or one or more services are throwing up errors. We can then go and drill down into those methods, and each invocation within that span can be visualized here to identify where exactly is the problem. At the top, we can see the complete time span taken for the first call or the top level call, and that calls these different services internally. Each of the service where it is failing or which one is having a problem can be visualized using this approach. So that was the three major things that we saw in this demo. For the first part, which is the logging, we used Loki. Then on the visualization for the distributed traces for Jaeger, we used the Jaeger UI itself. And for the metrics, we used Prometheus and Grafana. Now, I would like to give this suggestion to people about using the right tool for the right purpose. And I would like to share a small story about one of my friend who is visiting next month to US. He is having a trip to US, and nowadays people, if you are talking about something, I think we have to include AI in this talk. So this guy used AI chatbot to plan his trip. And the way he used it is, he wanted to visit maximum countries, and he wanted to maximize his usage of the KrisFlyer miles. So he went to ChatGPT or chatbot, and I said, I want to visit from Singapore to US, plan my trip in such a way that I visit most number of countries, and I also utilize my miles more effectively. So the chatbot was able to suggest him a trip which starts from Singapore, goes to China, takes a train from China to some other city. From there, he flies to Japan, from Japan to Seattle, and while coming back, he says, I want to come via Europe. So he is suggested to visit one of the Scandinavian countries and then take a flight from that country back to Singapore. What this AI chatbot was able to do is to find out some of these things in this trip planning which are not very obvious, like the partnership between Singapore Airlines and some other airline to suggest that you should take this or you should take the flight on a particular day to maximize your miles. So I think that's just an example where you use the right tool for right purpose, and you see some of these symbols related to travel. And I try to use that analogy to say that when it comes to observability, there are a lot of tools available in the market. Just because someone is using Loki or someone is using Grafana doesn't mean you have to use the same thing. Your use case might be different, your mileage would vary. So choose a tool which is more suitable for your use case, what your teams are comfortable with, what is really required for your business. And in that sense, here are some of the things or some of the recommendations depending on the challenges that we have. The first one, as I said, there are too many tools or too many agents might be required for you to implement the right observable solution. To overcome that, you can use something like OpenTelemetry. You don't have to really integrate your code with too many agents. You can rely on OpenTelemetry collector. Same thing goes for things like vendor lock-in and instrumentation. If you're using open standards, it becomes easier for you to switch from one vendor to another. So try to look for things, or even if you're relying on a vendor solution, look for things which are like following the open standards. So it's easier if you have to switch in future. Next couple of things are cloud native or cloud specific. So again, using things which are more cloud native helps you to build solutions which are portable, which are easier to move in, let's say, hybrid cloud scenarios. And having a single pane of glass, I think Grafana is more of a standard nowadays, but that's just one recommendation. With that, we come to the end of this discussion, and here are some resources. These slides, they will be published on Speaker Deck and SlideShare, and they're also available with the organizers. So if you are interested, you can get hold of them. And if you want to run the demo, it's available on GitHub. You can have a look at the demo as well. Thank you. Thanks for attending this session.